Yeah, I'm the last HSE speaker of the day, I'm sure you'll be glad to hear. And I'm going to be talking about visits. And we can see here a selection of real-time monitors. The ones on the left are low costs, and we compared results from them with a more standard laboratory grade one, the blue one on the right. The low cost one cost order of a couple £100. The thermo high cost one, the order of £1,000. So there's definite advantages for going for low cost. Real-time monitoring, in this case we're looking at optical particle counters and photometers. So just a quick introduction. There are light scattering devices. The response is proportional to the mass concentration, but it depends on so many other factors that it can be very difficult to get a reasonable calibration between something that looks at light properties of a dust and correlate that to something that is basically the mass concentration. They are low flow rate, and you can get particle losses in the sampling zones. There are two main types. There's an optical particle counter, which counts and sizes individual particles. They have very small optical measuring volumes, and the limitation is the maximum concentration they can measure. However, they do have the advantage in that you can get various size characteristics from them, PM, 2.5, etc. Because you can actually look at the raw size distribution data. Photometers, on the other hand, in a volume zone. Higher concentration range, but they don't have precise selection and can be oversensitive to fine aerosols. It means they tend to be better for the small respirable size particle fraction. This is part of work that started off with looking at laboratory evaluation of novel low-cost sensors, which we did in collaboration with TNO and NIOSH, and you may recognise one or two names below there. And this was just basically to study the performance in laboratory conditions where we can vary a large number of parameters and compare to respirable fraction. The type of result we got from these measurements is shown here, and this is just the results from one of the tests. And you can see you get on the graph on the right there, there's a number of optical particle counters and photometers, and you get reasonable calibrations compared to the gravimetric respirable concentration. At this stage, we're not that bothered about the slope and the intercept. That's more about calibration or correction. But you can see we're getting pretty good correlation coefficients. So these detectors, they work well in the laboratory. How well do they work in the real world? And for this, we piggybacked. Thank you. So on this, we piggybacked on Jackie's work looking at RCS. You've seen reasonable results in the laboratory, but when you go out into the real world, you do have calibration issues. You can have run into problems with high relative humidities causing troubles with the internal optics of the device. And this can cause baseline drift. And something that's also mildly annoying is they all record at different frequencies, making data crunching harder. You can see here, these are the monitors we used out in the site visits. We've got two optical particle counters, two photometers, cyclones there, and IOM sampling heads. So in more detail, the instruments we used was the PATS 7, a very simple photometer. It's got quite a large concentration measurement range, very similar to standard photometers. It's been developed mainly for biomass cooking and looking at environmental monitoring. It's very easy to use, but it does need zeroing before use. The AlphaSense optical particle counter was the other instrument we looked at. This has 24 size bins, so from that we can work out various size fractions, PM1, respirable, etc. Sorry? Oh, right. Is that better? Oh, I can hear myself now. Um, and then the laboratory photometer that we use is the PDR 1500, and you can see it's got a much higher concentration raised. It has size-selective inlet cyclones. We get a real-time display, and we've got filter for post-calibration. So that shows one of the main advantages of laboratory-grade optical particle counters, photometers, compared to these cheaper versions. We also did size distribution and respirable crystalline silica measurements, some of which Jackie mentioned. Briefly, because everything samples at different rates, there are a large number of size selection criteria. Many of the cheaper particle counters tend to use PM 2.5, PM 10, PM 4. In occupational measurements, we're more interested in the respirable and inhalable. And you can see there the respirable fraction is larger than the PM 2.5, but smaller than the PM 10. These are the three sites that we visited. The first one was sort of moderately dirty, and that involved mixing of various ceramic powders for such as frit into different mills. And you can see the first picture there. He has various bags that he's pouring into a mixing hopper with less than perfect ventilation, so there's clouds of dust appearing from the bottom around his feet area. The second was the brick manufacturer, and this was the very dusty environment, could do with a lot of improvement. And the third one was where they manufactured kitchen worktops and grave headstones. It may look dusty there, but that's more to do with condensation of water from the cutting process on the floor. So that would give us an indication of how high humidity may affect the results. So real-time comparisons, you can see here we've got the PDR in red, which is the standard laboratory grade, and we're comparing that to the PATS output. And you get very similar results. You can differentiate the different tasks. In this case, there's 3 different mixing processes which use different mixing compositions, different powder compositions, and you would expect from these that you would get a different calibration, because when you calibrate with samplers, you can only get one average measurement over the whole day. But we can use these to identify different peaks from the exposures, which is the main advantage of real-time monitoring over sampling. And actually, we even got a reasonable correlation between the results, which is generally problematic when you're comparing time series data. So this is the first comparison where we looked at the results from the optical particles counter, the AlphaSense optical particle counter, and looking at its PM 2.5 there, and we're comparing that to the respirable fraction. You can see it's very linear on the whole, apart from at the higher concentrations, and it is giving a response lower than the respirable fraction, which is what you would expect, and that's had a correlation coefficient of 0.8, which isn't too bad. What we've got there is the data from 3 different sites, from 3 different groups of samplers at each site. So the fact that we're getting a reasonable correlation is pretty impressive. Then looking at the PM10 fraction compared to the respirable, you can see we're getting a higher response rate as expected, but we're still getting reasonable correlation. And then looking at the PATS Plus sampler, which is the most basic, simple, cheapest detector out there, we get a very good correlation, surprisingly good as well, especially when we consider we're looking at different powders with different optical properties, and it's almost as if we're looking at the same dust. And just to reference back to Jackie's work, those are the kind of respirable concentrations we measured at the 3 different sites compared to the RCS values. Although this is preliminary results yet, we're still ongoing work, so there'll be more to come out of this. We've got another visit to do sometime in the future. The real-time monitoring from the cheaper detectors do show the tasks most likely to contribute to work air exposure as expected, and they can provide good information about the changes in concentration over time, so we can do relative measurements. The low-cost instruments show good agreement between traditional methods, laboratory-based instruments. However, all instruments do need maintenance and performance checks. One results I've not shown here is with the optical particle counter. We had a look at older, aged particle counters compared to brand new ones that hadn't been used before. The older ones, the optics start to get contaminated and they produced a lower response. So this is a work in progress, and the other problem with low-cost instruments is it's a rapidly changing market. For instance, the AlphaSense detector that we looked at, they've upgraded that, and I don't believe you can even get the particular version we used anymore. Thank you.